Throughout this class, we have periodically talked about the difference quotient. The limit of a difference quotient is referred to in calculus as the derivative, and is one of the most fundamental concepts of calculus there is. We will not be investigating it fully, but this is what this class has been leading up to. In this case, we're going to find the difference quotient of f of x equals x cubed, and also a different function in just a moment. In order to evaluate this, we first write out the limit. This limit is of h going to 0. Because this difference quotient is really the slope between two different points infinitely close together, h being the distance they are apart. Now the cube of h plus x will be x cubed plus 3x squared h plus 3x h squared plus h cubed. Now we can simplify this by canceling out x cubed and x cubed, in which case we are left with the limit of 3x squared h plus 3x h squared plus h cubed over h. If we now simplify by canceling out h's, and what we have left is the limit as h goes to 0 of 3x squared plus 3x h plus h squared. As h goes to 0, these become 0. They go to, because h becomes 0, and they effectively disappear. Therefore, the answer becomes 3x squared. In other words, we say, because the limit of a difference quotient is called the derivative, we say that the derivative of f is 3x squared, where, of course, f was x cubed. For a longer example, we're going to do f of x equals 2x squared minus 3x plus 5. Our first step is that we write out the difference quotient with the limit as h goes to 0. So f of x plus h is 2 times x squared plus 2xh plus h squared. That's 2 times the square of x plus h minus 3x plus h plus 5 minus, put it in brackets, 2x squared minus 3x plus 5, close bracket, divide by h. From here, the crucial part is to simplify carefully. So, we'll first expand this. We get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5 minus 2x squared plus 3x minus 5 over h. The terms we can simplify now are 3x and 3x, 5 and 5, 2x squared and 2x squared. This leaves us with the limit of 4xh plus 2h squared minus 3h over h. Notice that the constant term, 5, completely disappeared. It's no longer a part of the limit at all. That will always be true. Taking the difference quotient of just a constant, we can do each of these separately, one at a time if we needed to. The difference quotient of a constant, the limit of a difference quotient of a constant is always 0, because a constant is effectively a straight flat line, and the slope of a straight flat line is 0. To continue this problem, we next need to cancel out all the h's we can. This leaves us with 4x. Oh, h's cancel out. H cancel out there, cancel out there, cancel out here. Okay, so no x there, h there. 4x plus 2h minus 3. As h goes to 0, this leaves us 4x minus 3. Now, you will perhaps notice that this is in some ways very similar to what we started with. As you get into calculus, you will learn some basic simplifications that make this process much easier and much faster. It's important we understand this way first, but there are shortcuts you will learn when you learn calculus.